All right, so yeah, let's see what I signed up for. In the talk description, while the world was falling in love with desktop 3D printers as a potential disruption to how consumer products might be created and manufactured in the home, a parallel transformation was taking place that shows no sign of stopping. It is time to cut through the bullshit and examine the revolution that actually took place. All right, I'm Matt Griffin, Director of Community for Ultimaker North America. I'm a writer, community developer, adjunct professor, consultant, covering topics such as 3D printing, DIY electronics, and design for digital fabrication. I've been involved in desktop 3D printing from the beginning of this ancient art, which is like 2009. At first as part of the original team at MakerBot, where I was a community manager and helped to frame the concept of desktop 3D printing as a new market, evangelizing what is possible with this technology. I continued this work as a contributor to Make magazine, including co-starting their annual Make 3D Printer Shootout, Ultimate Guide to 3D Printing series, and then as Director of Community and Support at Adafruit, where I created 3D Thursday and authored over 3,000 posts about 3D printing and related technologies. I joined Ultimaker back in 2015, when we first put together a North American organization. I built the community team with the aim to engage our professional and education customers in North America and in the many contexts and fields in which they use our hardware, software, and materials. My favorite aspect to working for a company that makes 3D printers is that when we have the opportunity to engage with our users directly, we aren't just there to convince engineers and designers to buy something, like we would if we had just developed a product instead of a tool. Instead, the scenario flips the other way. It becomes our challenge to find ways to work for them and with them, to help them find ways that desktop 3D printing technology that we are recommending might actually help them accomplish their projects, designs, and inventions. So if this isn't your first Hope, you'll no doubt remember that there have been talks at Hope about 3D printing before, a bunch of them. About the technology in general, about adjacent topics like biological molecular compilers, implications of self-replication, impending disruption to our commodity-based capitalist economy, the thrilling specter of a desktop 3D printing revolution on the verge of toppling antiquated methods of manufacture, about IP rights and what this technology might do to the patent and trademark paradigms, and much more. The topic has come up a bit. I've attended many of these talks and have cheered folks on. I've had heated discussions with attendees and presenters about the latest thinking in 2012, and then 2014, and then 2016, and now 2018. And already today, I've had at least 2 serious-minded conversations with folks about the death of 3D printing, about treating the topic as something that concerned us in the past, with little air quotes floating around it, interrogating why in 2018 do we really give a flip about it. 3D printing is so hopeful, so 2012, so before the fall of civilization. Don't we have bigger fish to fry? So what I'm looking to share with you today is a bit more practical than has usually been shown here before, and a shift in, I'll mess with that in a second, and a shift in perspective. To offer a little bit of a spoiler for my own talk for a moment, if you look back at the total disruption that folks like me were thinking and prophesizing about 5 to 10 years ago, it's easy to feel like the promise of desktop 3D printing was something of a fizzle. But the point of my talk, if there is one, is that it is okay, and maybe even a very good idea, to continue to pay a lot of attention to this topic, even though the hype bubble certainly popped sometime back in 2014. There are still some pretty darned interesting things about this technology as it really works on the ground, and ways that you can leverage the hell out of it to create your next awesome projects. When the RepRap movement aimed and fired the idea of desktop 3D printing into the air, there were plenty of hypotheses about where it might have landed and how hard it might have come down. But the truth of the matter is that when it did come down, there wasn't a big boom or a mushroom cloud or the complete eradication of manufacturing technologies that had come before. Nope, the technology just sort of climbed out of its little crater, put on an awkward button-down shirt and glasses, and headed out into the big bad world. So before I get too far ahead of myself, let's circle back to clarify some critical terminology for our discussion. What does the term 3D printing mean? In general, 3D printing refers to a family of technologies that fabricate physical objects. These technologies center on the use of computer-guided devices to replicate a digital model in the physical world constructed from raw materials. This new paradigm reverses traditional manufacturing processes that typically involve first constructing molds and tools or applying tools to cut, carve, turn, melt, or otherwise subtract material from a larger original base material. At the conclusion of subtractive manufacturing, you receive your part along with a bunch of discarded waste materials. With additive manufacturing, you have the advantage of receiving just the part that you needed. Now, there is a good reason that the 3D printing definition that I just gave feels pretty vague and generalized, because it doesn't really commit to how the 3D model topology is defined, the job instructions produced, nor the chemical and mechanical means of building up the object. The specifics for these three areas differ according to each specific 3D printing technology. Another label used for this field is additive manufacturing. While this label is increasingly used to differentiate the higher-end industrial variants of this class of technologies, and in particular metal printing, and also extends beyond the automated fabrication process itself. In practice, the term is used pretty much interchangeably with 3D printing. So we have 3D printing and additive manufacturing as umbrella terms held up over an entire host of distinctly different concepts. It is possible to assemble an entire crowd of engineers where each has an entirely different idea about 3D printing, what it's good for, and how the technology works, and all of them can be right at the same time, even if the definitions and associations are completely at odds with each other. So a question that often comes up, can a 3D printer make anything? Well, this is a question that does crop up, but let me put it this way. A 3D printer can make anything it is capable of constructing within the confines of its build envelope, and using the materials and material properties it is able to combine to produce the object. Well, the 3D printers of today, excluding a handful of the highest-end Lamborghini sort of industrial cousins, are limited machines compared to fabrication lines you might stumble on in a modern factory. Remember that fancy bread maker your aunt gave you as a wedding gift? It fits on your countertop, sure, but you wouldn't expect it to offer all the industrial features you'd find in a commercial bakery, not to mention the staff of bakers. What you get is an automated process that should ostensibly result in bread being produced each and every time, and that's about the limit of the promise. So we've defined 3D printing and additive manufacturing. So what is desktop 3D printing, and how is it different? In the desktop plywood age, this brand new class of 3D printers didn't resemble the industrial machines at all. So the term was used more to explain how those laser-cut boxes bristling with breakout boards and exposed wiring accomplished something not completely unlike what rapid prototyping equipment was producing. But swiftly, the desktop 3D printing world has evolved into a tidier, well-functioning, pre-built machine kind of universe. And many of these, and in many cases, these machines and how they look are more recognizable to the public as 3D printers than their industrial counterparts. So other points of contrast between classes of AM technology were needed. The first obvious contrast as a key differentiator was the size factor. But then there emerged things like Re3D's Gigabot and BigRep and other medium and large format 3D printers whose pedigree were more with the desktop 3D printer universe than the older industrial AM approaches. And their build envelopes were much bigger than most of the industrial solutions. And so a more reliable gauge these days would probably be price. Desktop 3D printers are additive manufacturing devices that can be purchased for as little as a couple $100 up to $5,000 to $7,000. Over this amount, and the ownership of the machine shifts from being what an individual might pay for a trusted tool up to more of a business level investment. That factor is not a small one in determining the core values for this market segment, and we'll talk about that later. Several classes of desktop printers exist, from micro or portable to prosumer to professional desktop, and emerging from this desktop ecosystem are the benchtop, medium format scales and price points that I was mentioning earlier that do share a closer evolutionary link to desktop printers than industrial printers. These definitions vary from marketplace to marketplace, and no doubt clear definitions will be settled by the market sooner or later as certain elements become commodities completely and certain elements remain premium features. Okay, oops. Oh, I did it this way. So 3D printing technology has been around a long time. Let's see here. Okay. In order to update your understanding of the role of the technology today, I'd like to take you on a quick tour through the past, making stops along the way to consider the interesting potential trajectories as we understood them at that time. So let's head back to the 1980s. So it's been over 30 years since Chuck Hall invented and commercialized stereolithography, or SLA, back in 1984. Carl Deckard introduced selective laser sintering, SLS, in 1988. Scott Crump invented fused filament fabrication, FDM, in the late 80s and then commercialized it in the 1990s. And that's the most common form of additive technology used in desktop 3D today. So over its first 2 decades, the field of additive manufacturing brought under its umbrella a cluster of related but distinct technologies. There was also things like Z-Corp's binder jet printers, Connex multi-jet printers, RCAM, metal printers, so many more. So, should probably find out. Okay. So by the first decade of this millennium, there was already a firmly established place for 3D printing in the engineering, design, and manufacturing tool chain, and a number of machine manufacturers and service bureaus working in the space. The technology was typically used as an intermediate rapid prototyping stage to produce a physical sample of a part about to be manufactured so that all the stakeholders could assess whether the design was sufficiently complete and well designed for the business to commit to the expenses of delivering the design to a machinist, foundry, or factory. At that point, costly tools, molds, and factory lines would then be prepared for the production of the part in quantity. But the 3D printing machines of this era were on the whole bulky, refrigerator-sized pieces of equipment costing anywhere from $60,000 to millions of dollars for a single unit. And the parts themselves were quite expensive, hundreds to thousands of dollars. So engineers and designers making use of the technology tend to think twice before committing to producing a part. It won't surprise you to hear that there were very few replacement knobs for stoves and cosplay models produced with this technology at this time, though already there were artists and designers who found funding routes by hook and crook to produce unique works using this industrial technology. So the concept of a desktop 3D printer at this time was as alien as the idea of a pocket-sized mainframe computer might have been at the dawn of the computer age. But going back, so this early 2000s expectation for what additive technology was good for had emerged from the market that currently sustained those businesses. But this wasn't the full story. There were already the seeds of other ideas and purposes for the technology. So in order to go forward, we're going to head back a little bit to the past. The seeds of this approach to fabrication is actually as old as nature. Nature demonstrates the idea to us for how to construct big from the small: snail shells, oysters, bones, hairs, trees, tissues. These are not created by carving down and refining existing materials, the way most of our manufacturing methods work, but how mountains and geological formations were originally made, by bringing material together to build larger structures up or out, layer by layer, transformed by heat and pressure into final shapes. It was inevitable that this entire class of techniques to build up forms like nature would enter into our tools and how we fabricate and manufacture objects. And there were other precedents for how we were thinking about this kind of stuff. So Arthur C. Clarke introduced the idea of a replicator machine in 1964. Philip K. Dick published a children's book, Nick and the Glimung, in 1966 that had a plasticky alien that was described as printing a copy of anything presented to it. And Star Trek introduced the idea of the replicator, which was initially just a food molecular compiler in the original series, and then they introduced the term replicator in the Next Generation in 1987, which could make anything, not just food. So there's a little bit of a tricky chicken and eggs element to the fact that additive manufacturing as a concept was first cultivated in our cultural imagination, in fine art, comics, film, television, critical philosophy even, science fiction, and then decades later snatched out of pop culture as a handy means to explain a new class of digital fabrication technologies. So let's return to the early aughts when additive manufacturing technology has a clear role in the marketplace, and the OEMs continue to develop and tune the technology to secure and protect their particular share of that market. And let's add back the idea that the notion of a civilization reshaped by the pervasive use of a technology like rapid prototyping had already become firmly established in the popular imagination, thanks to art, television, philosophy, science fiction, like I said. So, I swear I have some slides that are not just numbers. But in 2008, entered the RepRap movement, which provided a bridge between those ideas and the existing technologies. So Dr. Adrian Boyer of the University of Bath proposed a compelling alternative to the industrial-grade 3D printers that had come before, inspired in part from these sources, together with his own academic background as a mathematician and an engineer exploring 3D topology. His credo: make them simple, make them cheap, make them so they can self-replicate. Drawing as much from how the world of culture and imagination dreamed of universal fabrication machines and matter compilers as from the history of additive manufacturing, he produced the idea of a RepRap, a replicating rapid prototyper. So the RepRap movement had begun, and as reprap.org, a key early platform for developing and evangelizing the movement, states, RepRap is about making self-replicating machines and making them freely available for the benefit of everyone. RepRap breeds tend to be designed from the ground up to be suitable for self-replication, relying on a combination of 3D printed and commodity-level components, such as aluminum extrusions, sliders, belts, pulleys, and similar, such that it is possible to share your BOM and build instructions with another machine builder in your area or halfway across the world, so that others can duplicate your efforts and benefit from your exploration. This community targeted fused filament fabrication first, the style of additive manufacturing where thermoplastics are extruded onto a build plate, building up to the final part layer by layer in quickly cooling plastic by tracing outlines and then filling in infill before moving up and repeating this process. The option had fewer critical moving parts than SLS or SLA, materials were easy to get, inexpensive, and it was much safer than the other AM materials. And most important, the base patents for this technology were expiring. So the RepRap movement aims to develop 3D printer breeds over a series of evolutionary leaps until eventually the goal of printer self-replication will be met completely. Currently, while many of the electromechanical components can be produced and have been since 2008 in pretty phenomenal and very difficult processes, the number of the components, such as sensors, microcontrollers, stepper motors, they're so difficult to produce using this technology, has resulted in an encouragement for the participants to source those as add-on parts or vitamins. As a consequence of the efforts to source parts and construct each needed component and the constant flux in models for parts and their configuration, RepRap units had tended to bear the fingerprint of the builder. So let's pause for a moment and take stock of how the world reflected on desktop 3D printing at this time. So the industrial ecosystem scarcely noticed the birth of RepRap. Industry knew what additive manufacturing was for, rapid prototyping, and while a few of the later arrivals into the space, like Z Corp, introduced the opportunity for lower cost, full color models that were favorably received by architectural firms and schools, the costs were still in hundreds of dollars per full-size parts. So not the democratizing of manufacturing that RepRap was calling for, but the visibility of these efforts were already starting to catch the attention of mainstream media. The RepRap ecosystem itself tended to be more taken by the idea and challenge of producing a self-replicating machine, and were not as concerned with actively using the results in other projects beyond the grand design of that far distant RepRap device that could easily spit out child printer after child printer, completely leveling the access to means of production. What the RepRap movement introduced definitively, as it grew like wildfire online and as a grassroots science fiction-fueled movement, was an ever-growing population of creative, innovative individuals thinking, what would I fabricate if I had my own 3D printer? What might change about my life and those around me? Different questions than the industrial users. And it is no coincidence that this year was also the year that Shapeways launched, offering consumers access to the means to produce custom designs, jewelry, and simple mechanical parts using technology that typically had only been available to industrial customers or B2B kind of pricing context. All right. So moving forward a year to 2009, to the birth of desktop 3D printing as a market segment. The problem that drove Zach Smith, future co-founder of MakerBot, on the journey that would lead to the creation of the MakerBot Cupcake CNC, the first affordable desktop 3D printer kit in the US, was that he needed a machine to help him produce more RepRap 3D printed parts more quickly. In parallel, Eric de Bruin, future co-founder of Ultimaker, was the first outside of Dr. Adrian Boyer's team to produce a working Darwin RepRap model from the BOM and instructions developed online. He and his co-founders offered RepRap building workshops at the Protospace Fab Lab in Utrecht, and they quickly set their sights on designing a machine of their own as a reaction to some of the frustrations they faced with the self-replicating constraints of that first RepRap breed. Similarly, back in the US, as Zach and crew started making working 3D printers, the focus on making those RepRap parts fell away pretty quickly. So self-replication and easy duplication are not requirements for desktop 3D printers in general. Desktop 3D printers target first and foremost the strategies that reliably produce objects. Emphasis is upon printing over producing printers. But the early history brings these two approaches together. So let's consider what industry thought of these new desktop machines and the arrival of the first MakerBot booth to CES, the Consumer Electronics Show in 2010. They really didn't get it at first. And having been so litigious with the other industrial competitors over the previous decades, they weren't quite sure how to navigate the expiring patents. Could they or should they squash what they saw as vastly suboptimal versions of their technology? Surely the clients who could pay for real additive manufacturing technology would never want parts like that. At the same time, their businesses as well were benefiting from a rising technology and mainstream reporter interest in this technology. On the other hand, from the perspective of those participating in desktop 3D printing world, quite a lot was happening. Probably more important than the launch of MakerBot Cupcake was the launch of Thingiverse, which preceded the launch of the machine. In general, participants in desktop 3D printing and the RepRap movement were not mechanical engineers as much as they were web developers, software developers, and drawing on other technology backgrounds. People who were thrilled to spend their time exploring how this new technology worked. Simply getting the machines to work at all was something deeply satisfying, in particular given how much of this activity was driven by participation and communication online. So ad hoc hacks and reverse engineered solutions from other industries flowed into Thingiverse, and all those participating as individuals or drumming up desktop 3D printing machine businesses participated in many of the same forums and online communities. People hadn't really been split out yet, they weren't yet fighting. And ideas for what would be worth creating with this newly accessible technology introduced new users and a vast range of interests and needs into the additive manufacturing ecosystem. From researchers pioneering the fabrications of living tissues to makers looking to transform their homes and workshops into new and zanier designs, there was room for everyone under this big tent. So technology and mainstream media took note and were taken with this storytelling and imagination of these young mad scientist troublemakers who were promising to transform the world through the use of their miraculous, if a bit unassuming looking machines. Just as long as you weren't that concerned about producing parts accurately or efficiently, you were all set, full speed ahead. For one very important reason, the cost to participate in this activity was pretty low. The machines, initially all DIY kits to be assembled, and ABS and PLA fabrication materials, initially simply using industrial plastic filaments designed for other fields, were cheap as well. The field was addictive, so very few got out of these machines precisely the funds and resources they put into them. But with the technology evolving so rapidly, simply keeping up with what was happening in this lively area and contributing what you could do as you did so was seen as a worthy goal to keep the hobby/addiction going. Welcome to the first faltering steps of the 3D printing desktop revolution. Okay, so now I'm going to leap forward a few years uh, over the early childhood of desktop 3D printing movement to 2012. This is when the machines became precise and reliable enough, and the market receptive enough, that the world truly began to take notice of desktop 3D printing. I'd like to address one of the desktop 3D printing's key early topics as a significant indicator to the role the media played in popularizing this technology, while also being its Achilles heel. This was the promise of imminent mass consumer adoption of this technology. Starting in 2012, the mainstream media struck up a long flirtation with what had been until then largely a tool of industry and a dream of science fiction. While their enthusiasm was contagious and probably attracted many of the young innovators and venture capitalists into a niche area they might have overlooked otherwise, several of these messages were misleading. Now, here is an opportunity for me to disclose my role in participating in these companies and marketing strategies. Because this technology was new to many of the journalists wanting to cover it, many more of the terms and statements repeated in articles and interviews have a more direct origin in the marketing departments of the young desktop 3D printing companies than would be typically okay in other areas of reporting. This isn't necessarily the printer manufacturer's fault entirely. Hopefully we can be granted some leeway for making efforts to build out these businesses and find new customers. And it probably sounded very good to us, the prospect of customers in every household on the planet. Well, we were inventing new approaches to branding and promoting the underlying concepts around 3D printing. And it was a lucky thing too. We came up with ideas that had enough staying power to take root in popular imagination even today. For example, Keith Ozar and Brie Pettis from MakerBot drew on backgrounds in entertainment, music, and film, and were not afraid to champion images from pop culture and science fiction that were well suited to expression over the internet. A big switch from the enterprise-friendly industrial video style presented by additive technology companies before them. So how brand and marketing works in desktop 3D printing is a key differentiator between what had previously felt industry-centric, inaccessible, when compared with the whimsical, inventive, high-energy, bleeding-edge associations the public has with desktop. And many of the longer-standing, popularly held confusions came from a very good place. The passions and dreams of those of us who approached desktop 3D printing as a mission, as a revolution. We saw this technology as the opportunity to reshape our civilization and commerce itself. And with this vision in mind, we wanted the gospel of desktop 3D printing to spread to every corner of the globe. It's a pretty romantic notion, right? So this forecast largely has not come to pass. What's more, there are compelling arguments that the technology hasn't yet uncovered a compelling enough reason to drive mass adoption. While the technology finds its way into more and more fields and occupations, there does still seem to be that prerequisite for ownership that 3D customers are those who already have a need for a tool capable of making digital designs into physical objects. So designers, makers, crafters, artists, inventors, students, educators, engineers, architects, doctors, dentists, all of these folks, they purchase their own home units and they go to town. So while a sizable group, not every shopper will fall under 3D printing spell, not yet. But as the media hype around this particular message fades away, it is too early to dismiss a bright future for this technology. Don't overlook the fact that there are actually more interesting and mind-bending things happening in this field now than at the peak of the popular interest in the technology. So now let's take a brief look at the rise and fall. And soon I will be done with my numbers. So now let's take a brief look at the rise and fall of the desktop 3D printer revolution, 2012 to 2014. From here, we can finally shift from talking about the anticipated future of desktop 3D printing over to where we ended up. So this period had some very high peaks. President Obama stating that 3D printing is the future in his 2013 State of the Union address. World Maker Fair's 3D printing area swelling quickly from a tent to an entire 3D printer village. The launch of Formlabs, 3D Hubs, E3D, the Prusa i3, and dozens of other printers and filament OEMs and other third-party tools and resources. The rise of the Kickstarter printers with PrinterBot and Formlabs as notable highlights. And as sad news, if you guys haven't noticed, PrinterBot has just closed doors, which is very sad. I was very tempted to do an in memoriam, and I thought that might be a little too grim for this. But there have been some great early contributors I've mentioned before that are no longer doing as much. So speaking of which, Ultimaker and peers like Type A Machines and Aleph Objects began shipping reliable pre-built machines not only to their original geographic areas, but to customers worldwide. The Enable movement sought to unite these squadrons and squadrons of individual desktop 3D printer operators to put their machines to use for a humanitarian effort and help those in need of assistive devices and open prosthetics research. So desktop 3D printing darling MakerBot, having launched the Replicator 2 on the cover of Wired magazine, was acquired by Stratasys for hundreds of millions of dollars, fanning the flames of additive manufacturing investment within the industrial space as well as the desktop space. So everything was on its way up and up, right? Just out of curiosity, have any of you seen the Netflix documentary Print the Legend? If you haven't, there's some interesting stories you can see about this time. So is everyone going to be getting on that rocket ship and blasting off into space? Okay, spoiler, that's not what happened. There's the offside case of MakerBot in a sprint to hit their target numbers for the earnout associated with the Stratasys acquisition, stumbling pretty badly, launching products that weren't ready for market. Other companies like 3D Systems announcing dozens of innovative new products to address the consumer space at CES, none of which ever reached the market at all. And while some of the best steps forward for the technology in this field actually took place during this time period I'm talking about, the precipitous rise and drop of stock valuations and more left many of those with bright eyes and earnest dreams of the early days of desktop in a pretty dark and disillusioned space. And that was definitely me for a while. So despite the tarnish on its reputation that inevitably follows the collapse of such impossible hype, 3D printing managed to get back on its feet, dust itself off, and get to work, transforming design, engineering, and manufacturing. So while the news outlets might have shifted to focus on other topics, and investors have shifted away from anticipating 10x multipliers in consumer-facing strategies in the field of desktop 3D printing, the field is actually still growing and getting stronger and playing a bigger role in our world. So desktop 3D printing is now more heavily in use in more professional and academic contexts than ever before. Young employees being hired right out of school at architecture and engineering firms are expected to have basic desktop 3D printing experience already under their belts. And what's more, this technology, what's once undervalued as a stepchild of additive manufacturing, is now on its way to be adopted at more stages of the product design, manufacturing, production, and in medical context than ever anticipated. It's starting even to push out higher cost industrial machines in many contexts. Why buy a high cost hero machine from the industrial space when you can purchase an entire room full of accurate, reliable, modular, and inexpensive machines to operate professional desktop equipment? The assumption used to be that the new and cheaper technology was just a lower grade version of rapid prototyping and additive manufacturing, not necessarily even worth the hassle when getting serious work done. So I'm going to switch modes a little bit and speak about what I'm seeing and experiencing right now from within the Ultimaker ecosystem. I believe, based on research and friendly relationships with folks at other peer desktop 3D printer companies, that this kind of trend that I'm going to share details about as I leave my number slides and actually show you some things, is similar to what is happening with some of the other professional desktop solutions, and so is speaking to what's happening in this field. So I hope you'll indulge me to share my personal field reports from this evolving story. One of the more exciting aspects of the evolution of the role of desktop 3D printing in professional design, engineering, and manufacturing processes are the new ways that this accessible, low-cost technology is being adopted in creative processes and in problem solving. 3D printer and additive manufacturing tools have long been assigned roles in prototyping. The first primary use and the initial label assigned to this technology was rapid prototyping, after all. And over the past 8 years, the field of additive manufacturing for custom parts and low-volume production has shifted from an idea that might work to what design firms depend on every week to keep pace with product development needs. Now, the tables have turned. In 2015 and 2016, professional desktop machines like the Ultimaker and some of our peers reached parity for resolution, quality of parts, range of materials, and other features with many of the more expensive industrial 3D printing cousins. Now, don't get me wrong, industrial additive technology OEMs did not rest on their laurels. Some innovative players in the industrial space have been constantly pushing the higher end of the AM higher and higher, delivering new and amazing impossible parts, from functional human trial kidneys and skull plates to 4D prints that propel themselves off the build plate when fabrication is completed, to semi-affordable metal 3D printing processes such as Desktop Metal, Formlab's 10K SLS machine, and Carbon's high-speed SLA process. But here is one of the first key insights. It is modest. It is definitely less sexy than saying this machine is revolutionary and disrupts industries. But here is the first evidence that this disruption is actually taking place. Engineers, innovators, and designers have come to realize that in most cases, they actually don't need anything more fancy or higher cost than, say, an Ultimaker printed part for most of the stages of design development. This doesn't mean that they don't like the look of a part hundreds of dollars or thousands of dollars more off a Fortis or an Objet, but what it means is that they can actually accomplish everything they need to do to make their designs better, to communicate internally and with clients within the professional desktop 3D printing world. So as the cost to produce parts using these desktop technologies continue to plummet towards what is perceived as practically free, these creators are finding other opportunities to take advantage of this ability to produce sturdy, functional printed parts in a range of materials. And as more and more workflows are driven by digital design these days, there are more opportunities and very little effort to use desktop 3D printers to produce parts, studies, sketch models, and jigs far earlier and during more stages throughout the design development process than anticipated. So I've been working closely with the 10X Beta team over at New Lab, and they're a fast-paced hardware design firm whose staff have been using 3D printing since before the technology was actually commercialized. So they've been in the 3D space for a very long time. And CEO Marcel Baltha said a few things I thought was interesting that reinforced this shift. He said 3D printer manufacturers in desktop have reached the inflection point where these desktop units are perfectly sized to fabricate relevant sized objects, and the resolution is superior to machines that cost many multiples more. And he also said, even more crucially, the industrial additive manufacturing companies missed the point as far as providing what is critical for prototyping. With our machines, we can finally use 3D printers for experimentation on the fly. The original aim of iterating and rapid prototyping was, at the end of the day, to prototype and not to produce costly artifacts at each stage. In other words, while the industrial 3D printer companies continue to advocate for a leading position based on costly, challenging capabilities, the clients themselves realized that to accelerate their design processes, they really just needed on-site, easy-access desktop 3D printing. Most of what they need is to glance at, poke at, and pass around a printed part, and then chuck it in the trash. And having a tool like ours and a lot of our peers that keeps the cost per print low strongly reinforces this kind of behavior and makes printing a natural and reflexive part of the digital design process. So I want to share a little bit of the sort of new landscape of desktop 3D printing and share some examples of some things I've been seeing. So we sort of have identified these 5 areas in the professional world as being the places that desktop 3D printing is completely ready to move full speed. So product development, which won't surprise you, a lot of prototyping is there, but also manufacturing aids, in-use parts, architecture, medical. Desktop 3D printing has long been a huge ally for education, and we'll talk about that too. But I want to go through a couple of these in more specifics. Okay, so product development. So we're kind of splitting this out in terms of these 4 areas. So concept direction, some of the early stages of figuring out what the problem is. Now, it might not seem like an exciting thing, but in the past, to produce the CAD, to make the part, to use this kind of technology for this, it really wasn't indicated. But now, with people being much more comfortable using digital design tools, and the digital design tools themselves being, better, matched into the context where they can get things out to 3D print them, you're seeing new kinds of behaviors. And this doesn't work if you're having to fill out a PO every time you print an object. So concept and directions, shape and form. You have an object that you can print things that are strong enough that you can really test them up against other objects. You can test interface. You can cast and mold from it. It's a great tool for that. And then the classic split for prototyping looks like, works like. You can actually take both areas further than a lot of the other technologies. And one of the key things and reasons why is you're putting all the actual information into the digital design. A 3D printed part is less real than a digital design. It's a state. And if you do this process right, you're constantly bringing the information back into the digital design. And so when you're looking to make a functional prototype, you're not spending a whole lot of time going from, here's my design idea, and let's get to where we can test it. You can constantly tune and tweak on the digital side and get that instant feedback as you bring it into the tangible world. Same with looks like prototyping. You can do more things to these shapes. You have that physical shape, and it can be handled and experienced like the real thing. So I want to share a couple of projects that people have been doing. I'd mentioned 10x beta, and here are a couple of models for a project. I'll actually switch down to it. The Dart metrics. So they've been doing a couple of fitness training robots. They did one with Puma that was designed to be able to give Usain Bolt a challenge on the track. It's pretty insane project. So they decided to make one that would be suitable to NFL training. So this is a robot that is monitoring the person who is following them and is capable of keeping up and exceeding the performance of pretty impressive athletes, to really give them a challenge and allow be grabbing data the whole time to really understand what elements can be improved, what the athlete's skills are, that kind of thing. So in these images here, so they started printing some early concepts to get like a sense of what it would be like. Cool. What it would be like to, what the concept should look like, how it might function. And what is really interesting to me, they went through a long process and they identified some really useful things to them in their communication with their clients. But then when they went to do mock-ups, they found that they had a little bit of a problem, that some of these concepts, they just couldn't turn fast enough. They would topple. And so they started really rethinking the project at that point, changing the materials, that kind of thing. Well, they had the CAD because they had developed it in working through all these designs. So they end up using 3D printing, not for the outer surfaces, not for the outer facing of these objects, but for all the brackets and stuff to be able to make this thing quickly. So they could mock it up and test it, and get it all the way to really solving that problem. Here's another little project. They've just got some attention recently. They did a lot of the engineering and electronics side of this. So this is a project that is to help monitor patients and hourly rounds in hospitals. And they had a very specific constraint of where they could put it. And they had to get a lot of sensors and information into it. And the experience of it socially had to feel not like some surveillance thing, but something that would be pleasant to receive and experience, because you need adoption from the nurses as well as the patients and everybody. So what's interesting about this is, as they were developing it and printing out the enclosures, they were able to accommodate using off-the-shelf development electronics and constantly be changing how they were including the elements while putting it into a pertinent sized frame to give feedback. So they kept tuning and tweaking how it behaved internally as they miniaturized electronics and finally committed to things. So manufacturing aids is an area we didn't actually expect to be. but one that is huge. So while a lot of manufacturers are using our kinds of stuff to make handy jigs and fixtures in general, we're also seeing things like install aids, like this story from Volkswagen, which I'll share here. So in Portugal, the team there has a whole room full of 3D printers, and they're using it to make all the handy tools for installing parts of the car. And it's not that these parts are so precious; it's that they're heavy use. They get destroyed really fast, and they had been working with outside firms to have these made, and it gets pretty costly pretty fast. So by bringing it in-house, they not only were able to save money to produce these things at minimum cost, but they were able to refine them, tune them, tweak them, and use them in the process of really changing how they're used and how the onboarding process happened. Production and in-use parts. Just briefly mention two stories here. So one is actually jump down here to Farm Shelf. So Farm Shelf does a desktop size, like a bookshelf size hydroponics rig, 250, 300 custom parts. They had to develop a modular set and iterate that entire modular set. And there was no funding route that they could pay to make those custom parts while they were still identifying what would be the right solution. So they were able to iterate the entire 350 custom parts like 11 times without ever committing to tooling or injection molding. So I'm definitely running out of time. So I'm going to invite anyone who's interested afterward to definitely connect with me. I want to talk to you. I can share some of these other stories. But I want to mention one last story in my last 30 seconds here in architecture. So 3D printing has been part of the architecture story for a very long time. But what is interesting is we're seeing firms like KPF who are experimenting with taking printers out of the model shop, out of the situation where you're submitting a part and somebody's running it, hand it back to you, and putting it back within the direct access of architects and designers. And by having their own access and being able to iterate when they want, as they want, and communicate internally before filling out POs and really committing to costly processes, they're accelerating what they're doing. So this, even though it doesn't seem like a very fancy use, this is incredibly accelerating their vast and distributed team across 7 sites. Okay, so I should probably wrap up. But thank you all very much for coming.